Hello, calculus students. Today our lesson is on differential equations, and this kind of steps off of our slope fields lesson. Problem 1 here says, consider the differential equation dy dx equals negative 2x over y. On the axes provided, sketch a slope field for the differential equation at the 12 points indicated. So, this is just creating a slope field like we've been doing. Let's start at my favorite point, 1, 1. If I sub in a 1 for x and a 1 for y, then this is a slope of negative 2. So something like that. How about if I'm at the point 1 for x, 2 for y? That's going to give me negative 2 times 1, so that's negative 2, divided by 2, which is going to be negative 1. What if I'm at the point 0, 1? If it's 0 for x and 1 for y, then that's going to be 0 over 1, which is 0. And 0, 2, same thing. 0 over 2 is 0. In fact, I think if we go down here to 0 for x, negative 1 for y, that will be 0. And 0 for x, negative 2 for y will also be 0. So lots of zeros here. What about at negative 1, 1? Negative 1 for x is going to give us negative 2 times negative 1, which is 2. Divided by 1 for y is 2. So it should look like a reflection across the y-axis from this one we had to start. Next, we've got negative 1, 2. Negative 1 for x is going to give us negative 2 times negative 1, which will be 2 on the top. And then 2 for the y, so 2 divided by 2 is going to give us 1. So this will be a reflection here. All right, 1, negative 1. 1 for x, negative 1 for y. That's going to give us negative 2 over negative 1, which will be positive 2. And then 1 for x, negative 2 for y. It's going to be negative 2 divided by negative 2, which is 1. Negative 1 is going to give us negative 2 times negative 1, which is 2 on the top, divided by negative 1 for the bottom is going to be negative 2. And negative 1, negative 2 is 2 over negative 2, so that's negative 1. All right, hopefully you're getting pretty good at filling out these slope fields now. On part B, it says, let y equals f of x be the particular solution to the differential equation with the initial condition f of 1 equals negative 1. Write an equation for the line tangent to the graph of f at 1, negative 1, which is the point we're talking about here, and use it to approximate f of 1.1. So whenever you hear tangent line, pardon me, all year long, you need to go y minus y1 equals m times x minus x1. That's our go-to tangent line formula. So now what can we fill in? What do we know? Well, we know that we have this point, 1, negative 1. That's our x1, y1. So we'll go y minus negative 1, which would be plus 1, equals something times x minus 1. But we need the slope. Where do we get the slope? Well, this is still working off of the same differential equation. We're on part B of this problem, okay? So we can substitute in our point 1 for x and negative 1 for y, which we actually already did when we came up with this one. So that's going to be a slope of 2. And if you wanted to do the workout, it'd be dy dx is equal to negative 2x over y. So this is going to be negative 2 times x of 1 divided by negative 1. So that equals 2. So we're filling in a 2 here for the tangent line equation. So when it says write an equation for the tangent line to the graph, this is what we have right here. That part of the problem is done. Then it's kind of like two parts in one, because it also says to use it to approximate f of 1.1. So that means if I substitute in a 1.1 for the x, I'm going to solve for y. So we'll go y plus 1 equals 2 times 1.1 minus 1. So 1.1 minus 1 is 0.1. 2 times 0.1, and we could add subtract 1 from both sides to get y by itself here. So 2 times 0.1 is 0.2, and then if you subtract 1 from that, you get negative 0.8. So that's the approximation for 1.1 based on the tangent line equation. So basically the idea here is that if you have a tangent line equation, it gives you values that are pretty close to whatever the actual function would when you're close to the point of tangency. And 1.1 is obviously going to be pretty close to the negative 1 point that we have as our point of tangency. So we can use the simple linear equation to solve for values, approximations for values on the function that are close to the point of tangency. Okay, for part C, it says find the particular solution y equals f of x to the given differential equation with the initial condition f of 1 equals negative 1. Does that sound like a mouthful or what? That is a lot of shuns in an equation. In a sentence. So this one is going to require a little bit more work, a little bit more space. So I'm going to do this one on a separate sheet of paper, okay? And I would recommend that you do the same because there's not room here. So for number 1, part C, we have this differential equation that they gave us. dy dx equals negative 2x over y. And we also have the point 1, negative 1. So when it says find the particular solution, y equals f of x, what they're wanting you to do is basically undo the derivative by integrating and get a y equals equation that would correlate. So the way we're going to do this is we're going to use the method of cross multiplying. Y'all have done this a bunch of times before, solving proportion kind of problems. So we're going to say y times dy equals negative 2x times dx. And then we are going to integrate both sides of the equation. Integrate y dy and integrate negative 2x dx. So when you integrate y, you use the power rule backwards. Add 1 to the power on the y, which will give us y squared. Multiply by the reciprocal of that new power, 1/2. And we're not going to put plus c here because there would be a plus c on both sides of the equation. So when we do problems like this, we are going to add the plus c only on the x side for consistent practice. So over here on this side, I'm going to add 1 to my power, so it's going to be x squared, and then I'm going to multiply by 1/2, the reciprocal of my new power, but that 1/2 will multiply by the negative 2 already here, so that actually just equals negative 1. So I'm just going to put negative x squared here, and then I'm going to put my plus c on the x side only. So I'm going to come back to this equation in a minute, so I'm putting a little star by this step to kind of notate it so that I know where I'm going back to. But I'm now going to substitute in my 1 for the x and my negative 1 for the y in my equation and solve for c. We're actually going to get a c value here. So 1/2 times negative 1 quantity squared equals negative 1 in parentheses squared. Watch out, because this negative is being squared, and this one is not. So you've got to very carefully plug in these values, watching your signs so that you don't make mistakes. And then plus c, so negative 1 squared is 1, so that's a half, and this is negative 1 plus c. To get the c by itself, I'm going to add 1 to both sides. 1 plus a half is 1 1/2 or 3/2. There's my c value. So now I'm going to return to the equation where I started before I subbed in the x and y from my point. And I'm going to rewrite that equation with the c value replaced with the number I just solved for. So 1/2 y squared equals negative x squared plus 3/2. Now, we technically have solved the differential equation at this point in time. However, because it says it wants it y equals a function of x, we do need to get the y by itself in this equation. So I'm going to multiply everything by 2. So I have y squared equals negative 2x squared plus 3. And then we normally would have to say I'm going to take the plus or minus square root of both sides. However, this answer is supposed to be a function of x. Y equals a function of x, so it should only have either the positive root or the negative root, and it does matter which one we choose. We need it to go through this point. So if I go square root on both sides to cancel out that square, do I want a positive in front of this root, or do I want a negative in front of this root to travel through this point? Well, if I want y to be a negative number, I'm going to need a negative in front of the square root, because you're never going to get a negative output from a square root. So it should be the negative root. And that's going to be something you're going to need to watch for to make sure that you have this sign correct, because that is a common mistake. So this is the answer to the problem. That's what we're looking for. Okay? And that is a big part of the gist of what we're doing in our lesson today. We're going to practice on a bunch of different problems. So number 2 says, consider the differential equation given by dy dx is equal to x times the quantity y minus 1 squared. On the axes provided, sketch a slope field for the given differential equation at the 11 points indicated. I'm going to ask that you pause your video and try to do this slope field problem on your own, and then come back and check. All right, I'm going to assume that you did it on your own. If x is a 0, then this whole slope is going to equal 0. So along my y-axis, I have horizontal lines. If y is equal to 1, 1 minus 1 is 0. 0 squared times any x is going to be 0. So when y is 1, I also have horizontal slopes. So there's really only 4 that I have to actually crunch out. 1 for x, 1 times anything is itself, and 0 for y. So 0 minus 1 is negative 1, squared is positive 1. So this one should be positive 1. 1, negative 1, 1 for x, negative 1 for y. Negative 1 minus 1 is negative 2, squared is 4. So that's very steep. Now negative 1 for x and 0 for y. Negative 1, 0 minus 1 is negative 1, squared is positive 1. So this one should be a negative 1 slope. And negative 1, negative 1. Negative 1 minus 1 is negative 2, squared is 4, times negative 1 is negative 4. Very steep. So there's our slope field. Now, part B says, use the slope field for the given differential equation to explain why a solution could not have the graph shown below. Why would this not be able to be a particular solution for this given slope field? It's kind of similar in shape. It has a 0 slope along the y-axis. It has a positive slope here. What's the problem? Well, On this slope field, when y is equal to 1, we have a slope of 0. It's like a wall. And when y is 1 here, I definitely have a positive slope here and a negative slope here. So the reason why the solution could not have this graph is because at y equals 1, the slope should be 0, and it is definitely not in this picture. Okay, part C, find the particular solution y equals f of x to the given differential equation with the initial condition f of 0 equals -1. So this is the same instruction that it gave you on number 1, part C. So we're going to do the same thing again for number 2, part C. 2C, we have the differential equation here, dy dx equals x times the quantity y minus 1 squared. And do they give us a point? Oh yes, f of 0 equals -1. So 0 for x, -1 for y. Okay, so we're going to solve this one just like we did for the last one. This time when we do this, I'm going to talk to you about how this is scored on the AP exam free response questions, because I want you to get all the points for these, and they do give a lot of points for these, and this is a very common AP free response problem. So the first thing we did on the last problem was we cross multiplied. I don't have one fraction equal to another fraction here, but I can make that happen by putting a 1 underneath the right-hand side. And now I'm going to cross multiply. So I have 1 dy equals x times y minus 1 squared dx. Now, we do not have our variables separated. We need all the y's on one side with the dy's and all the x's on the opposite side with the dx's. So how do I make that happen? I'm going to divide both sides by y minus 1 quantity squared. So I'm going to say, let's say y minus 1 to the -2 power dy equals x dx. All right, now we have separated the variables. Y's on one side, x is on the other. So at this point, we've earned 1 point for our free response work. Okay, separating the variables is worth 1 point. Now, we're going to integrate both sides. So how do I integrate this? Well, on the left side with my y's, I'm going to need to do a u substitution. So I'm going to say u is equal to y minus 1, du dy equals 1, du equals dy. So I can rewrite this as the integral of u to the -2 power, and du and dy are the same, so I'll just go through and put du. On the right side, I could go ahead and integrate. If you integrate an x, you do power rule backwards, so that's x squared to add 1 to the power, multiply by the reciprocal of my new power 1/2, and then I need a plus c on the x side only. Now to integrate over here on the left side, I'm going to do power rule backwards also. So this is going to be u to the -1, because -2 plus 1 is -1, and multiply by the reciprocal of -1. -1 is -1 over 1, so when you do the reciprocal, that's 1 divided by -1, which is still -1. And I'm not going to put a plus c on this left side, only with the x's. So I'm going to rewrite this as -1 over u, but I'm going to take the u out and go back to y minus 1. So that I don't have u's, I have my y's back. Okay, so here I have finished my integration. Now, as far as points go, sometimes they give you 1 point for integrating both sides correctly. Sometimes they give you 1 point for each side. So 1 point for the x's and 1 point for the y's. So at this point, we've either earned 2 or 3 points. And they often will give you a point for putting your plus c as well. So actually, we would have 3 or 4 points already. You see how this is adding up? Now we're going to sub in our 0 for x and our -1 for y. That's going to give us another point. So I'm going to go -1 over, oh, and I'm going to put a star here because this is the step I'm going to go back to before I subbed in the point. So -1 over -1 minus 1, I'm subbing in the -1 for the y here, equals 1/2 times 0 for x squared plus c. So this is -1 over -2, which would be 1/2, and then 0 plus c is just c. So now I have the c value. Finding that will also get you a point. And now I'm going to go back and put that 1/2 in for c. So I'm going to have -1 over y minus 1 equals 1/2 x squared plus 1/2. And then the last point that you get on this problem is going to be for isolating y. To write it y as a function of x. So how do I do that? How do I get the y by itself? It's in the denominator. That's never good to have it in the denominator. I have a lot of fractions in this problem. It's all kind of gross. Since I have 2 1/2s, I think I'm just going to multiply every single term in the problem times 2, just to make it less fractiony. Is that an adjective? Okay. And now I want to get that y out of the denominator, so I'm going to multiply both sides of the equation times y minus 1. And that means I have -2 equals x squared plus 1 times y minus 1. Now I want to get the y stuff by itself, so I'm going to divide both sides by x squared plus 1. So I'll have y minus 1 equals -2 over x squared plus 1. Basically what happened here is my x squared plus 1 switched places with my y minus 1. Okay. Now to get the y completely by itself, all I have to do is add 1 to both sides. So -2 over x squared plus 1 equals y. And that is the answer that would get you the last point for this problem. All right, these problems are not short, but I would argue that most of the time they're not that hard if you've practiced them like you need to. And so that means that they're a good way for you to rack up some points on your AP exam and get that high score that you're after. So let's practice on this some more. For number 1 here, I have y prime equals 5x squared divided by y, and we're going to go through the point 1, 1. First thing I want you to do when you see a problem like that is get rid of that y prime and call it dy dx, because we're going to cross multiply and we need to separate the variables, okay? So if I separate the variables, I'm going to cross multiply y dy equals 5x squared dx. That's a point, separating the variables. Now we're going to integrate both sides. So power rule backwards, 1/2 y squared equals 5/3 x cubed plus c. Integrating will either get you an additional point or an additional 2 points. Getting the plus c will get you a point. So we're racking up points right now. I'm going to put a star by this because I'm going to sub in x of 1 and y of 1 now to solve for c. 1/2 times 1 squared equals 5/3 times 1 cubed plus c. So this is 1/2 equals 5/3 plus c. I'm going to subtract 5/3 from both sides, but I'm going to need a common denominator. So let's call the 1/2 3/6 minus 5/3 would be 10/6. And when you subtract, you're going to get -7/6 for c. So I'm going to go back to the equation. 1/2 y squared equals 5/3 x cubed minus 7/6. Whoops. I'm so sorry. Got down here too low. So these problems on the back don't say specifically to write y as a function of x. So technically right now, after you have subbed in your c value, you could call it done. If you wanted to practice getting the y by itself, because they often do tell you to write y as a function of x, all you'd have to do here is multiply both sides of the equation times 2, everything times 2, and then take the square root on both sides. And since our point has a positive y value, we would want the positive root only. All right, so that one is done. Let's look at number 2. We have f prime of x. As soon as you see f prime of x, change it to dy dx. Square root of x on the top over 2 f of x. What is f of x? F of x is y. They're using this funky notation to mess with your brain. Don't let them. You know what those things mean. Change them to the notation that is more comfortable for you. Now, f of 1 equals 12. This means we have the point 112, so this will be our x and this will be our y. So we're going to cross multiply 2y dy equals x to the 1/2 dx. Separating the variables earned us a point. We're going to integrate both sides. Power rule backwards. Y squared equals x to the 3/2 times 2/3 plus c. We're going to put in a 12 for the y and a 1 for the x. And this is the step I'm going to go back to. So 144 minus 2/3 will equal c. 144 minus 2/3, let's see, 144 times 3 minus 2, this is 430 as an improper fraction, or you could say 143 and 1/3 as a mixed fraction, mixed number. So I'm going to say y squared equals 2/3 x to the 3/2 plus 430 over 3. And it doesn't tell me to write y as a function of x, but if I was supposed to, I'd have to take the square root on both sides. And since my point has a positive y value, I would want the positive root here. Okay, let's take a look at number 3. And we're going to skip number 4 because it is a whole lot like, see this x, y minus 1? This was x, y minus 1 quantity squared, so it's almost just the same as this problem, except for maybe a little easier. So we're going to skip that one. We're just going to, oh, but you would want to write that as dy dx, by the way. Okay. Back to number 3. Put a 1 under this right side. Cross multiply. 1 dy equals 3 square root of x times y dx. We need to separate the variables, so I'm going to divide by y on both sides. So I'm going to have 1 over y dy equals 3x to the 1/2 power dx. Now I'm going to integrate both sides. So the integral of 1 over y, this is not power rule backwards. Remember, that's y to the -1, and if you add 1 to that power, you end up with a 0. And if you try to multiply by the reciprocal of 0, you end up with an undefined value. This is a note card. The integral of 1 over y dy is the natural log of the absolute value of y. We're going to hold off to put our plus c over here on the right side with the x. Add 1 to the power. 1/2 plus 1, which would be 2/2, is 3/2. Multiply by 2/3. The 2/3 gets multiplied by the 3, so that's just going to be a coefficient of 2. And then we need our plus c. Okay, so we're going to come back to this step. We're going to sub in 0 for x and 4 for y. So the natural log of 4 equals 2 times 0 to the 3/2 plus c. So c is equal to the natural log of 4. All right, so we'll go back to this step. Natural log, absolute value of y, equals 2x to the 3/2 power plus the natural log of 4. Now, how do you get the y by itself here? Well, you have to remember your stuff your Algebra 2 teacher taught you, which is, you should have learned the definition of a logarithm. The log base b of the argument is equal to the power when the base raised to the power equals the answer. Okay, this is the definition of a logarithm. These two statements are equivalent to each other. So we're going to do our little switcheroo here. We right now have a logarithmic statement. The log base e of our argument, absolute value of y, is equal to this power. So we're going to rewrite this as an exponential statement. The base is e raised to this whole thing as the power equals the argument of the log, which is the absolute value of y. Okay, so I will tell you they do these in the multiple choice problems a lot, and they fully simplify the answer. You might be going, that looks like it's fully simplified to me, Mrs. Heiss, but it is not. And by the way, if you do not remember this, you probably want to add that to your note card stack and study it, because that is something you're going to need to be familiar with for the AP exam. All right, there's another little property that I want to remind you of. When you were in algebra, you learned that if you had x squared times x to the third, that you could put those together by adding the powers. Do you see this plus here? This can be broken up by saying e to the 2x to the 3/2 power times e to the natural log of 4. Why would we want to add in another e? Well, because that natural log of 4 can simplify with the e. E to the natural log of 4 is just 4. Remember the base of e on the natural log? These are like inverse operations. They cancel each other out and you're left with the argument. So 4e to the power of 2x to the 3/2 equals the absolute value of y, or really just y. We don't have any logs here anymore, so we don't need to worry about the y being a negative. Not a problem. Okay, that would be the answer you'd be looking for in the multiple choice section. You will see more like this in your assignment so that you can practice. All right, let's look at number 5. If I can get it all on here. Given that the quantity x squared minus 4 times dy dx is equal to x over y, determine the solution to this differential equation that would pass through the point 2, 5. Okay? So, the first step, separate the variables. I'm going to cross multiply on both sides. So I'm going to have y times x squared minus 4 dy equals x dx. And we've got a problem here because we got x's and y's on the same side. So I'm going to say y dy equals x over x squared minus 4 dx. And now I'm going to integrate both sides. I've separated the variables. how do we integrate on the right side? Well, let's do the left first. Oops, and this is a dx. The integral of y dy is 1/2 y squared. And on the right side, we have to use a u substitution. The denominator is the u. U is equal to x squared minus 4. Du dx is 2x. Du equals 2x dx. I do already have an x in the problem, so 1/2 du equals x dx. So I'm going to rewrite this as the integral of 1 over u times 1/2 du. And now I can pull that 1/2 out in front and just integrate 1 over u, which is the natural log of the absolute value of u, but I'm going to put x squared minus 4 back in place of the u, and then plus c. So this is integrated. We're going to sub in our point, 2, 5, 2 for x, 5 for y. So 1/2 times 5 squared equals 1/2 natural log absolute value 2 squared minus 4 plus c to solve for c. So 5 squared is 25, 1/2 of 25. Well, let's just call it 25 halves. 1/2 natural log of c, 2 squared is 4. 4 minus 4 is 0 plus c. What is the natural log of 0? Do you remember from Algebra 2 that your natural log graph has a vertical asymptote on the y-axis? We don't take natural logs of negative numbers or of 0. This is outside of the domain of the natural log function. This is undefined. If this is undefined, how do we find c? We do not. There is no solution to this problem because the solutions to this differential equation will never pass through that point. It's impossible. So, important to know that you may not always get a solution to every differential equation. All right, this is our last problem. This last problem is going to rely on a lot of Algebra 2, and I feel like I've been talking about Algebra 2 a lot today. The growth rate for a population of fruit fries, it would be nice if it was French fries and not flies. Okay, fruit flies is proportional to the number present. The initial population was 100 flies, and after 4 days, there were 500 flies. Find an expression for the population P at any time T. All right, in Algebra 2, you learned an exponential growth model, a general exponential growth model. It was kind of like the PERT formula. Students seem to remember the PERT formula for continuous compounding money a lot. But it was like the output is equal to the starting value, so y naught is your starting value, times e to the power of kt. Or in money, you did a equals p e to the rt. That's your PERT formula. It's the same thing. That's just in context of money, principal, and the amount that you're left with, the rate, the interest rate, and time. So k here is our interest rate, y naught is how much we start with, and y is what we end with. So notice it says after 4 days, there were 500 flies. The initial population was 100 flies. So we end with 500. We start with 100, and then e to the k times 4 days for time. So this equation will allow us to solve for that growth rate. We're We're trying to find that growth rate for this proportional relationship. So we divide by 100 on both sides. 5 equals e to the 4k power. We use that definition of a logarithm. The log base e, so the natural log of the answer to the exponential is the argument of the log, equals the power 4k. Some people also just like take the natural log of both sides to get this answer. And then you can either multiply by 1/4 or divide by 4 on both sides to get k by itself. Either one is fine. So the population is equal to the initial value times e to the power of kt, which is natural log of 5 over 4 times t. That's in the power, y'all. I'm sorry. I probably should have written that bigger so that it looked more like a power, because the fraction power is hard. There we go. That's better. That looks better. All right. So, what will the population be after 10 days? Well, to get that, you're just going to sub in a 10 for your time. And you could do that with your calculator if it was a calculator problem, which it likely would be, or else you'd just leave it like that. 100 times e to the power of, let's go 10 times the natural log of 5 divided by 4. So that looks like it'd be 5,590.1699. Okay, 0.170. And you would round to 3 decimal places unless explicitly told to do otherwise. And you do have to have that 0 there. You can't just write 0.17, because when you round to 3 decimal places, you have to show numbers in all 3 places unless it comes out to a perfect exact answer, no rounding. When will the population be 1,000 flies? Okay, so that means the ending value is 1,000, and we're trying to solve for the time. So the first thing we would do is divide both sides by 100. So that means 10 would equal e to the natural log of 5 over 4 times t. You can take the natural log of both sides to rewrite this as a logarithmic statement. The natural log of 10 is equal to the power natural log of 5 over 4t. And then to get the t by itself, since I've got t times a fraction, I'm going to multiply by the reciprocal on both sides. So 4 over the natural log of 5 times the natural log of 10 is equal to t. Or you could just write that as one fraction, would probably look better. 4 natural log of 10 over natural log of 5 equals t. And that's the answer. Or if we did it as a decimal, let's see, we would have 4 natural log of 10 divided by natural log of 5. So the time would be approximately 5.723 days. All right, that is our lesson today. Good luck on your homework. Have lots of fun. Let me know if you need help, and have an absolutely wonderful day. I'll talk to you soon. Bye for now.